Hello everyone, my name is Tal Reis and I'm a PhD student at the Hebrew University of Jerusalem. I'll be presenting our work, Efficient Discovery and Effective Evaluation of Visual Perceptual Similarity, a Benchmark and Beyond. So this is a joint work with Oren Barkan, Jonathan Will, Ori Katz, Roy Hirsch, Itzik Malkiel, and Noam Cohenstein. And this is a joint work from the Open University of Israel, the Hebrew University of Jerusalem, the Technion, and Tel Aviv University. So we are going to discuss visual similarity discovery, and I want to start with the task definition. So given an image of a certain object, visual similarity discovery retrieves images of different objects with high perceptual visual similarity. So this is different from the common image retrieval task, also known as the identification task, where the goal is to retrieve images of the same object. And why is it important? So this question has many examples in practice, like in search-based content. So there are image-based search, where we want to search for objects that are visually similar to a query, and also for recommendations. So in this case, we are recommending items that are visually similar to the query image. So visual similarity discovery is a discovery task, and our task is to determine if a gallery image is similar to the query image. So we observe a gallery image and rank. If we get high rank, we say it's similar to the query. If it's low rank, we say it's not similar. And basically top ranked gallery images are expected to be similar. So I want to speak about the problems and limitations of the current methods, and they are divided by these two things. That first, auxiliary information is used in current methods. For example, they can use either tags, metadata, collaborative filtering in information, or even explicit data from users in order to learn better visual similarities. However, such auxiliary information is clearly often unavailable, and even when it is, it may not be faithful proxy for perceived similarities. An additional difficulty with learning identification as a proxy is multiple images of the same product are often unavailable. And of course, there is no publicly available labeled dataset for visual similarity discovery. So in this work, we address the challenge of discovering and curating a visual similarity dataset with using human domain experts. So there are a few naive approaches for labeling visual similarity discovery datasets. And the first one is brute force labeling, where human experts label all query candidates pairs in the dataset. And this is really non-efficient, right? You can see here the numbers are really high. So for really small datasets of 10,000 images, we have to do 4.5 years or 24 hours work. So in our work, we propose the efficient discovery of similarity methods, the EDS, that enables the efficient discovery of positive pairs. So EDS utilizes a set of vision models to form a set of pairs suspected to be positives. These suspects are then reviewed by experts that determine whether each suspect pair is indeed positive. And the main assumption behind EDS is that models can serve as a proxy similarity measure on the pairs in the dataset, and hence the produced set is likely to contain high fraction of true positives. However, this method comes with model bias. So our ground truth labels are biased towards the models, right? So this bias leads to bias in standard retrieval metrics such as hit rate and MRR. However, we propose the ROC AUC metric for evaluation, as the ROC AUC quantifies the ability of a model to rank positive pairs higher than negative pairs, regardless of their absolute rank. So in our paper, we propose two benchmarks. We utilize the deep fashion dataset with both its in-fashion close retrieval and also the consumer to shop close retrieval. And we propose two benchmarks. The first one is the closed catalog discovery, and the second one is the image in the wild discovery. So closed catalog discovery is basically based on the in-catalog datasets, and the task is to retrieve images associated with different objects, which are similar to the item of the image query. And basically, we randomly selected 2,000 queries to form really high, more than 50,000 query candidate image pairs that were evaluated by our domain expert. The second benchmark is the image in the wild one, and the task is to retrieve images of similar items from the in-catalog retrieval task, where the query images are basically wild images, basically low-quality ones that are taken by users. So we also we randomly selected 2,000 queries to form more than 60,000 query candidates, image pairs that were evaluated by our human domain expert. So to conclude, our evaluation is based on the ROC AUC, which mitigates the model bias. Identification baselines fail on visual dissimilarity discovery, and however, visual dissimilarity discovery is far from being solved, as current state of the art is in about 75% ROC AUC. So this is it, and I hope you enjoyed the conference.